All right, so let's start off again, going back to the pure substances. So remember, the pure substances here are off to the left, and it's just breaking it down into elements and compounds. So we'll start there with the pure substances. So a sample of matter that has definite chemical and physical properties are elements. So again, elements are pure. That means that that is as pure as they can get. You cannot break anything down further. Like here, you see the example is oxygen, right? And that's just a little square out of the whole periodic table. And so here you have oxygen is an element, right? So again, oxygen, carbon, nitrogen, gold, silver, platinum, those are all elements and they don't get any purer than that. So elements are made up of little things called atoms. If you're thinking about atoms, atoms are the building block of everything, of all matter. So they're kind of like the Legos of the universe, right? That's how I like to think of atoms, is because pretty much everything is made of atoms, right? They're just the building blocks of everything. The sun, the stars, like the sun is a star, the moon, everything, right? You are made out of atoms. And so atoms are the simple basic building blocks. But if you put two or more atoms together, then you get right here what is called a molecule, right? So that's why you see these two little red circles together. Each one is supposed to be an atom. And when you put two atoms together, you get a molecule. Sometimes these molecules can be made up of the same atom and they're still pure elements, right? So if this is an oxygen and this little red one is an oxygen, it's still pure oxygen, right? There's just two of them together. Over here, you have this compound. Again, this is little Mickey Mouse looking head. And this is like an example of H2O, right? These little red ones are the hydrogens, H2. That's why it's a two, because there's two of them. And then O would be like this oxygen right here, this Mickey Mouse head. And then these two red things, the ears, would be the hydrogens, right? And this is an example of a compound. And we'll get to that in a little bit. But remember, an atom is just a building block. A molecule is two or more of these atoms put together. And then we'll talk about compounds right now in a little bit, in a little more detail. So here we have the periodic table, right? This is what I've been saying over and over again, is that these pure substances, they can't be separated into anything simpler by physical or chemical means. That's just as pure as they get. So here, oxygen, we saw earlier, I kept talking about silver is right here, gold is right here, AU, AG is silver, PD is platinum, then mercury. They use the Latin names for some of these. That's why AG is silver, right? Because if you wanted to use an S is already being used by sulfur, so they use Ag. But anyways, this is as pure as these things can get. So if you see them on that periodic table like this, that means that you can't break it down into anything simpler, right? So all of these are elements, but all of these elements, again, the basic building blocks of each one are atoms. So hydrogen atoms, lithium atoms, sodium atoms, they all act very differently. So a hydrogen atom acts differently than a lithium atom. A lithium atom acts different than an Na sodium atom, and so on, right? But again, pure as they get right here. So some elements are made up of a single individual atoms, right? This is what we were talking about, the basic building blocks, the Legos of the universe, like I said. So every one of these is supposed to represent an atom, right? It's just a simple model, a simple drawing of an atom, just so you kind of get the idea of it. We're actually going to go into more detail of the atoms later, but for now, this is enough just to be like, okay, this little black dot right here is supposed to be an atom. This is an atom. They're all atoms of the same kind, right? Same shape, same color, everything. So that's what they're supposed to represent. Right? But then you have other elements are made of molecules. So remember what we say, molecules are two or more atoms joined together. And so here you see in the drawing, right? There's just two of them stuck together, bonded together. In each of these examples, the elements are composed of only one type of atom, right? So let's pretend these white ones right here are hydrogen. That just means that there's a hydrogen and a hydrogen, a hydrogen and a hydrogen, a hydrogen and a hydrogen. It's all pure hydrogen though, right? So that's why it's a pure element of hydrogen, even though there's two of them stuck together. Again, there's two hydrogens stuck together. So it's still pure hydrogen, right? Still a pure element. And here I'll show you again, hydrogen is this first little square right here at the very top. Right, then we have compounds. So compounds are pure substances composed of two or more different elements joined by chemical bonds. So don't be surprised if you see this further on, right down the road, is if they're asking the difference between a molecule and a compound. Remember, the big difference is that the compounds are made of different elements. So here you see H and O, right? Two H's, one O. Here you see NaCl. Na is sodium, Cl is chlorine. Here you see carbon and oxygen.